Good evening, friends. So, today we will talk about LCM and HCF. So, to start with, what is the definition of LCM and what is the definition of HCF? What do you mean by LCM and what do you mean by HCF? And then how to calculate it, and then we will look at a few questions which have appeared in different examinations on LCM and HCF. Okay, so to start with, what is LCM? So, guys, what do you mean by LCM and what do you mean by HCF? Okay, so when we talk about LCM is basically the smallest of all the numbers which divide the given set of numbers. So, for example, when I say there are two numbers, say A and B, both of them will have certain multiples. So, A will be multiples of A would be 2 times A, 3 times A, 4 times A, and so on and so forth. Similarly, multiples of B would be 2 times B, 3 times B, 4 times B, and so on and so forth. The smallest number, which is a multiple of all the given numbers, is called LCM. Similarly, when I talk about HCF is the highest common factor. So each and every number will have certain number of factors. So the largest number, which is a factor, which is a common factor of all the given numbers, is a HCF. By the name itself, it says highest common factor. By the name, LCM means lowest common multiple or least common multiple. So it is basically the smallest number which is a multiple is a LCM, highest number which is a factor of all the given numbers is a HCF. Now, second question is how to calculate HCF. So there are two ways. One is prime factorization method. Second is division method. So division method is the same method which we have studied in class 3rd, 4th, 5th, which I believe we all know. And there is one more method which is a prime factorization method. Now, for example, if we have to calculate LCM and HCF of 72, 288 and 1080, how do we calculate LCM of these numbers and how do we calculate HCF of these numbers? So let's try to do it with the prime factorization method first. So let's break each and every number into its prime factors. So prime factors of 72 would be 3 cube into 2 square, 288 will be 2 raised to power 5 into 3 square, 1080 will be 2 cube into 3 cube into 5 raised to power 1. Now, prime factorization method says that LCM is product of all the highest power of each and every prime factor. So, when we talk about LCM, we talk about highest power of each and every prime factor. So, what's the highest power of 2? Now, before that, what are the prime factors of these numbers? Prime factor of these numbers will be 2, 3 and 5. Now, what is the highest power of 2? Highest power of 2 among all the three numbers, 2 raised to power 3, 2 raised to power 5, 2 raised to power 3. Highest power of 2 is 5. What is the highest power of 3? 3 raised to power 2, 3 raised to power 2, 3 raised to power 3. What is the highest power of 3? 3 raised to power 3. What is the highest power of 5? Highest power of 5 is 5 raised to power 1. So LCM of these numbers would be 2 raised to power 5 into 3 raised to power 3 into 5 raised to power 1, which comes out to be 4320. So LCM is nothing but product of highest power of each and every prime factor. Similarly, when we talk about HCF is product of minimum power of each and every prime factor. So for the same set of numbers, what will be my HCF? My HCF will be 2 raised to power 3 into 3 raised to power 5 and into 3 raised to power 2. Okay, so what are the powers of 2? Powers of 2 is 2 raised to power 3, 2 raised to power 5, 2 raised to power 3. What's the smallest power? The smallest power is 2 raised to power 3. Yes? And similarly, what's the smallest power of 3? The smallest power of 3 is 3 raised to power 2, 3 raised to power 2 and 3 raised to power 3. So smallest power would be 3 raised to power 2. Now coming to the 5. Now we can see the smallest power of 5 is 1. But then in the other numbers, can I say there was a multiply of 5 raised to power 0, which is nothing but 1. So lowest power of 5 would be 5 raised to power 0, and my HCF would be 2 cube into 3 square, which is 72. Yes, that is how to calculate LCM and HCF using the prime factorization method. So when I say prime factorization method, it is basically LCM is highest power of each and every prime factor, HCF is lowest power of each and every prime factor. Now going a step further, from this, can I say if there are two numbers, say A and B, they will have certain powers of each and every prime number. Now all the highest powers will be combined in LCM and all the smallest powers would be combined in HCF. So can I say LCM into HCF will be product of the two numbers? Because if I say it is 2 raised to power A into 3 raised to power B into 5 raised to power C, and let's say B is 2 raised to power Z into 3 raised to power Y into 5 raised to power X. Now if 2 raised to power A is okay, if A is higher than X, A is higher than Z, then 2 raised to power A will be a part of LCM and 2 raised to power Z will be a part of HCF. Wherein if Z is higher than A, 2 raised to power Z will be a part of LCM and 2 raised to power A will be a part of HCF. Similarly, if B is higher than Y, 3 raised to power B will be a part of LCM and 3 raised to power Y will be a part of HCF, or vice versa. So can I say all those numbers will be either a part of LCM or a part of HCF. So basically LCM into HCF would be product of all the numbers. Yeah, but it is applicable if and only if there are two numbers. If there are more than two numbers, then this rule will not be applicable. Now another method is the division method. Now how to do the division method? In division method, if we have to find the LCM and HCF of the same set of numbers, we will calculate the LCM of HCF of the two numbers which are the larger ones first. So basically we will divide the largest number from the just smaller number. So if I divide 1080 by 288, it will go 3 times. I will get 864 and my remainder would be 216. Now I will divide my original number or the previous number with the new number, with the new remainder. Again, it will get I get a 72. Now I divide the previous remainder, a previous divisor with the remainder, and it completely divides. So the last divisor will be my HCF. So 72 with HCF of 288 and 1080. Now if 72 is HCF of 288 and 1080, can I say HCF of this number and 72 will be the HCF of overall number? Now if I divide HCF 72 by 72, it will simply divide it once. So HCF of these three numbers will be 72. Yeah, which is same as what we got in the previous questions, as previous method as well. Now LCM, how to do LCM? So we will write all the numbers side by side. We will look at the common factors. So a number which can divide all the three numbers 72, 288 and 1080, 2. Okay, if I divide all of them by 2, I get 36, 144 and 540. If I further divide by 2, I get 18, 72, 270. If I further divide by 2, I get 9, 36 and 135. Now I cannot divide by 2 any further. So let me try dividing by 3. So if I divide all the three numbers by 3, I get 3, 12, 45. Can I further divide by 3? Yes, I can further divide by 3 and I get 1, 4 and 15. Now over here there is no set of 2 or more numbers which have a common factor or which can be divided. Okay, so we will just stop here. Then we will simply multiply all the numbers. Okay, so 2, 2, 2, I will multiply 3 times 2, which is 2 cube. then 2 times 3, which is 3 square, with 1, 4 and 15, and I get the LCM. This is how we calculate LCM using the division method, which I believe we all have studied in good length during our school days. Now we'll just look at a few questions. Any doubt till now? Anything which you guys want to ask? Anything which you guys could not understand? Okay, we'll move to a few questions. We'll have a look at a few questions. So your first question is, find the number of co-primes of 120 which are less than 120. Yeah, how to do it? What will be the answer? How many numbers will be co-prime to 120 which are less than 120? Okay, take a minute, try to solve it. Now, first of all, what is a co-prime number? So, co-prime numbers are those numbers or those pair of numbers who have a HCF of 1. So, for example, if I talk about 5 and 6, 5 and 6 are co-prime because they don't have any common factor, or in other words, their HCF is 1. So, if I look at 5, 5 is 5 raised to power 1, 6 is 2 raised to power 1 into 3 raised to power 1. HCF of these two numbers would be 1 because there is no common factor. So, how many numbers will be co-primed with 120 which are less than 120? So, can I say any number which is co-prime with 120 will not have any factor of 120? Now, what is 120? If I look at 120, 120 is 2 raised to power 3 into 3 raised to power 1 into 5 raised to power 1. So, any number which is not co-prime will be a multiple of either 2 or 3 or 5. So, when my question says find the number of co-primes to 120, can I say my question is how many numbers less than 120 are neither multiple of 2 nor multiple of 5 nor multiple of 3? So, I just need to remove the multiples of 2, 3 and 5. Now, how to do it? Instead of looking at how many are co-prime, let's look at how many are not co-prime. So, how many multiples of 2? So, multiples of 2 less than 120 will be 60. How many multiples of 3? 40. How many multiples of 5? 24. Now, how many multiples of 2 and 3? So, 2 and 3 would be 20. Okay, and how we get this 60? 120 upon 2. Every second number is a multiple of 2. How we get this 40? Every third number is a multiple of 3. Every fifth number is a multiple of 5. So, if I simply divide 120 by 2, 3 and 5, I get these numbers. How we get this 20? Divide 120 by 2 and 3 both. How many numbers are multiples of 2 and 5? It will be 12. How many multiples of 3 and 5? So, 3 and 5 will be 8. Then how many numbers are multiples of 2 and 3 and 5? It will be 4. Now, when I say how many numbers are either multiple of 2 or multiple of 3 or multiple of 5, how do we do it? Okay, we will simply add. Okay, remember set theory Venn diagram. When we said intersect, okay, union of A, B and C is A plus B plus C minus A intersection B, B intersection C, C intersection A plus A intersection B intersection C, which will give me how much? It gives me 124 minus 54 plus 8, which gives me 124 minus 54 will give me 70, 70 plus 8 gives me 78. So 78 numbers are there which are co-primes with which are either multiple of 2 or 3 or 5. So the balance 42 are the numbers which are which are neither multiples of 2 nor multiples of 3 nor multiples of 5 and which are co-prime with 120. Does it make sense, guys? Guys, have you got it? Okay. Is it correct or wrong? Okay, so tell me it is 56 plus 8. Which makes it 88. Okay, so my answer would be 32. It's not 42, it's 32. Now another way of looking the same thing can be, can I say if every second number is a multiple of 2, every second number is not a multiple of 2. So let's look at how many numbers are not multiples of 2. So 1 upon 2. How many numbers are, okay, now every third number is a multiple of 3. So out of every 3 there will be 2/3 of the numbers which will not be multiples of 3. So into 2 by 3. Similarly, if every fifth number is a multiple of 5, out of every 5, 4/5 of the numbers will not be multiples of 5. Now if I solve it, I will again get 32, which is my answer. So there will be 32 numbers which are neither multiples of 2 nor multiples of 3 nor multiples of 5 and which are co-prime with 120. Okay, moving to the next one. In how many ways 210 can be written as product of two numbers A and B which are co-prime to each other? Yeah, just take a minute and try to solve it. In how many ways 210 can be expressed as product of two numbers A and B such that both A and B are co-prime? Now again look at the factors of 210. What are the factors of 210? Can I say 210 okay upon 2 is 105, 105 upon 2 is 105 upon 2 is 102, sorry, 102 upon 30 upon 3 would be 35. So it is basically 2 into 3 into 35 is 5 into 7. So basically 210 is a product of 2, 3, 5 and 7. Now in how many ways I can write 2 into 3 into 5 into 7 in such a way that these two numbers are co-prime to each other? So if two numbers are co-prime, one way can be, okay, let's say there are two numbers A and B which are co-prime and which multiply to give me 210. So can I say 2 can be a part of A, 2 can be a part of B as well, 3 can be a part of A, 3 can be a part of B as well, 5 can be a part of A, 5 can be a part of B as well, and similarly 7 can be part of any one of the two numbers. So basically, can I say there are two possibilities with 2, two possibilities with 3, two possibilities with 5, and two possibilities with 7. So in totality, in 16 ways, I can write 2 into 3 into 5 into 7 as product of two numbers which are co-prime. But the problem here is, there will be one case when you will say, okay, 2 is a part of A, 3 is a part of A, 5 is a part of B, 7 is a part of B. Okay, and there will be another scenario wherein you will say 2 is a part of B, 3 is a part of B, 5 is a part of A, 7 is a part of B. So there will be 16 ordered pairs. So if you consider that, okay, A and B are two distinct numbers, okay, A and B can and is different from B and A, which we call is the ordered pair, there will be 16. But if you say in how many ways it can be written as product of two numbers, my answer would be 16 upon 2, because in 16 pairs, each and every pair will be repeated twice. So if each and every pair will be repeated twice, how many numbers, how many pairs will be there? My pairs will be exactly half of it, which is 8. But how many ordered pairs? It will be 16. Okay, coming to the next one. In how many ways 17 factorial can be expressed as product of two co-prime numbers? So when I say 17 factorial, if you remember the previous question, I am only concerned with the number of prime factors of the numbers. Okay, it does not make a difference whether it is 2 raised to power 7 or whether it's 2 raised to power 8. In the previous question, had it been 420, my answer would have remained the same, because in that case it would have been 2 square. Okay, so I would have said either 2 square will be a part of A or will be a part of B. It cannot happen that, okay, 1 2 is a part of A, 1 2 is a part of B, because in that case it will not be co-prime. So in this case, I am just looking at what are the factors of 17 factorial. So if I look at factorial 17, it is 2 raised to power some number into 3 raised to power some number into 5 raised to power some number into 7 raised to power some number into 11 raised to power some number into 13 raised to power some number into 17 raised to power some number. So can I say 1, 2, 3, 4, 5, 6, 7, there are 17 prime factors of 17 factorial. So in how many ways? Again, there are two numbers A and B. This 2 raised to power A can be a part of either A or B. Similarly, 3 raised to power B will be a part of either A or B. So with all these nine powers of prime numbers, I will have two options. So how many ordered pairs would be there? 2 raised to power 9. But question is asking me, in how many ways it can be written as product of two co-prime natural numbers. So I have to divide this number by 2, and my answer is 2 raised to power 8. Is it okay, guys? Have you guys understood this? Okay, moving to the next one. What is LCM and HCF of these two numbers? Okay, so when I say LCM of these two numbers, we talked about LCM. LCM is the highest power of each and every prime factor. So can I say it is 2 raised to power 4 into 6 raised to power 3 into 5 into 7? Yes or no? No. Reason being, when we said we have to take the highest or the lowest power, we have to take the prime factors. 6 is not a prime number. So first of all, I need to break my number into its prime factors. How to do it? It is 2 cube into 2 cube into 3 cube into 5, which makes 2 raised to power 6 into 3 की power 3 into 5 raised to power 1. Similarly, my second number will become 2 raised to power 6 into 3 raised to power 2 into 7 raised to power 1. This is wrong, and my LCM would be highest power of 2 is 6, highest power of 3 is 3, highest power of 5 is 1, highest power of 7 is 1, and my HCF would be lowest power of each and every prime number. So lowest power of 2 is 6 and lowest power of 3 is 2. Lowest power of 5 and 7 will remain 0 each, which makes it 1 1. So my LCM is 2 raised to power 6 into 3 raised to power 3 into 5 into 7. HCF is 2 to the power 6 into 3 raised to power 2. Hope it makes sense. Okay, moving to the next one. LCM of all the numbers from 1 to 120 is L, and LCM of all the numbers from 1 to 125 is L into N, wherein L and N are some natural numbers and you have to find the value of N. Guys, take a minute and try to solve this question. Okay, so when I say LCM of all the numbers from 1 to 120, can I say L is highest power of each and every prime factor from 1 to 120, and L into N is highest power of each and every prime factor from 1 to 125. So when I talk about L, now first of all, what's the difference between L and L into M? L and L into M, the difference is basically 121, 122, 123, 124 and 125. Now what is 121? 121 is 11 square. Now can I say L is a multiple of 11? Because there are a lot of numbers which are multiples of 11 till 120. So there will be a number 11, there will be a number 22, 33 and so on and so forth. So L is a multiple of 11, but L into N has to be a multiple of 11 square because 121 is included now. So can I say in L, I have to multiply a 11 to make it a multiple of 121. L was already a multiple of 11. To make it a multiple of 11 square, I have to multiply an additional 11. Now coming to 122, 122 is 61 into 2. Now L is already a multiple of 61, L is already a multiple of 2, so L is already a multiple of 122. I need not to do it any further. 123 is 41 into 3. Now L is already a multiple of 41, L is already a multiple of 3, L is already a multiple of 123. I need not to do anything further. Similarly 124 is 31 into 4. So L is already a multiple of 124. I need not to do anything further. Now next number is 125. 125 is 5 cube. Now L is a multiple of 5 square, 5, but L is not a multiple of 5 cube. To make it a multiple of 5 cube from 5 square, I need to multiply an additional 5. So LCM of all those numbers will be L into 11 into 5, which is 55L, and value of N would be 55. Yes guys, I hope you guys have understood this. So basically, when you include a few extra numbers, you just need to look at how many of these extra numbers have some extra powers or some extra prime numbers. So if there is a prime number extra, you have to multiply that prime number in the LCM. If there are some extra powers, you have to incorporate those extra powers into your prime numbers. Okay, so this is what you guys need to do. Okay, next question is, LCM of three numbers 12 raised to power 24, 16 raised to power 18 and A is 24 raised to power 24. How many values of A are possible? Okay, so first of all, what is 12 raised to power 24? Look at the numbers. Let's break the numbers into its prime factors. So 12 raised to power 24 is 2 raised to power 48 into 3 raised to power 24. Reason being 12 is 2 square into 3 raised to power 24. Similarly, 16 raised to power 18 is how much? 16 raised to power 18, 16 is 2 raised to power 4. 2 raised to power 4 whole raised to power 18 will become 2 raised to power 72. Yes. And third number is A, which may have certain powers of 2 and certain powers of 3. Now coming to 24 raised to power 24. Now what is 24? 24 is 2 cube into 3 raised to power 24. So it is basically 2 raised to power 72 into 3 raised to power 24. Yes. So far so good. Now I am looking for powers of 2 and 3 in A. Now the minute I say LCM of these three numbers is 2 raised to power 72 and 3 raised to power 24. Can I say that the highest power of 2 in the three numbers have to be 72, highest power of 3 in the three numbers have to be 24, which I already have got it. Okay, my first number is 2 raised to power 70, 2 raised to power 48. My second number was 2 raised to power 72. So I already received the power of 2 as 72 and power of 3 as 24. So can I say power of 2 in A raised to power in A can be any number from 0 to 72, and power of 3 in A can be any number from 0 to 24. So there are 73 possibilities with powers of A, and there are 25 possibilities with powers of 3. So 73 into 25 will be my answer, will be the possible values of A. Now question is how to solve 73 into 25. So can I say 25 is nothing but 100 into 4. Probably multiplying by 25 was slightly difficult, but dividing by 4 is slightly easier. Why? Because dividing by 4 is nothing but reducing a number to half twice. So what's half of 73.73? Half of 73 is 36.5. If I further divide by 18.25 multiplied by 100, and your answer is 1825. Yes guys? Now your answer is 1825. Okay. Looking at the next one. Your question is sum of two natural numbers is 420 and their HCF is 3. How many such pairs are possible? So there are two numbers whose HCF is 3. Can I say two numbers are 3A and 3B, and their sum is coming out to be 420, which means A plus B comes out to be how much? A plus B comes out to be 140. Now what is 140? 140 is 2 square into 5 into 7, which means, okay, so far so good. Now when I look at 140, I have to write 140 as sum of two natural numbers. Now for the HCF to be, okay, second thing which we need to take care of is A and B in this question, in this statement has to be co-prime. So A and B cannot have any further common factor. because if there is a common factor beyond 3, my HCF will not remain 3. So if I say okay, A is 2 and B is 138, so 2 into 3 and 138 into 3 will give me a HCF of 6. My HCF will, okay, and which is my prime condition. So my prime condition will go for a toss, which means both A and B have to have no common factor. Now how is it possible that none of them are, okay, both of them does not have a common factor? So that is possible if your numbers are neither a multiple of 2 nor a multiple of 5 nor a multiple of 7. Now in how many ways 140 can be, how many numbers less than 140 are neither multiple of 2 nor multiple of 5 nor multiple of 7. So half of these numbers are multiple of 2, we'll remove it. 1/5 of those numbers will be multiples of 5, so I will take the balance 4/5, and then 1/7 of those numbers will be multiples of 7, so I will remove those and I will take the balance. So this gives me how much? 2 into 5 is 10, 7 to the 14, so 2 into 4 8, 8 6 are 48. So there are 48 numbers less than 140 which are neither multiple of 2 nor multiple of 5 nor multiple of 7. And what will be those numbers? Those numbers will be, one number will be 1, okay, and one number will be 129. What will be the next number? 2 is not there, 3 is not there, 4 is not there, 5 is not there, 6 is not there, 7 is not there, 8, 9, 10, 11. So next number will be 11. So similarly for 139 there will be one number 129. Okay, if you look at all the numbers in between these two, 130 is a multiple of 2, yes. So all the numbers in between these two will be a multiple of either of the two numbers, yes. Okay, so if there are 48 numbers which are neither multiple of 2, 3, 5, okay, in how many ways I can do it? My answer is 48 upon 2, which is 24. Yes. Okay, moving to the next one. There are two natural numbers x and y who have a HCF of 7. In how many ways? If the product is 1, 2, 3 is 4, 8. So if number are 1, 2, 3, 4, 8, two numbers who have a HCF of 7 will become 7a and 7b. So if I divide both sides by 7, 7 square 49, I get a into b equal to 252. If I divide this number by 49, I will get 252. Now 252 is how much? 252 is 2 square into 3 square into 7. Now again I have to divide this number into two parts such that their HCF is 1. So how to do it? Either of these three numbers will go to go to first number, and either of these three numbers will go to second number. So I have got two options with 2 raised to power 2, I have got two options with 2 raised to 3 raised to power 2, and two options with 7 raised to power 1. So in totality I will have 2 raised to power 3, 8 options. So in 8 ways these numbers can go to either A or B, but then every number will get repeated once, just like what we discussed a couple of questions back. So total number of ways would be 4. So in 4 ways this number, okay, there are 4 pair of natural numbers whose HCF would be 7 and product would be this number. Okay, so that's all from my side. So we have got a few comprehensive sessions for CAT 2021 GK module, There is a CAT. Okay, so if you guys are planning to prepare for CAT 2020, there are a few courses, few batches which are there, which are still running. You can join that. But if you are actually preparing for CAT, I will suggest you to join CAT 2021. Start preparing for CAT 2021, for which there is a comprehensive course which we are starting, which we are running in Gradeup. For any query, on our courses, you can call on this number 96500 then there are different subscriptions which you can join. There are subscriptions for 3 months, 6 months, 18 months, which you can pick, and you can take up any of the courses for us with us. Okay, that's all from my side today. Thank you for joining Grade Up sessions. Thank you.